Here are your solutions to 5-6. These are the letter problems. We'll start with letter A. Our first problem says Mr. Parsons wants to build a new banister for the staircase shown. If the rise of the stairs of a building is 5 feet, represented right here, and the run is 12 feet, what will be the length of the new banister? So in other words, we're obviously looking for a hypotenuse here. So we have a good generic equation to use here would be that the hypotenuse equals the square root of a leg squared plus the other leg squared. So in this case, this is going to be the square root of 12 squared plus 5 squared. And that's going to be the square root of 144 plus 25, or the square root of 169. And again, if you just plug this into the calculator right from the start, you're going to see that we have a distance of 13, and we're dealing in feet, so our unit is feet. 13 feet for letter A. Problem B. The top part of a circus tent is in the shape of a cone, so we can see the cone here. The tent has a radius of 50 feet, so that's right here. That's obviously a leg. And the distance from the top of the tent to the edge is 61 feet, so obviously we're looking here at a hypotenuse. So we need to find the distance of the other leg. They ask how tall is the top part of the tent, round to the nearest whole number. I'm going to do this like I showed you. In order to calculate a leg, your generic formula could be that one of the legs equals the square root of the hypotenuse squared minus that other leg squared. So in this case, that leads to the square root of, we have 61 feet for hypotenuse, so it's 61 squared, minus one of our legs is 50, so that's 50 squared. That equals the square root of 3,721 minus 2,500, and that is the square root of 1,221, and that comes out to about 34.9428. And remember, everything we're doing here is to the nearest tenth normally, but this particular problem said round to the nearest whole number. Well, the nearest whole number to this is 35. So we have 35 feet. Please do guided practice. Here are your solutions to 5-6, guided practice. First of all, it says write an equation, and make sure you do that. Write an equation that can be used to answer the question and then solve that equation round to the nearest tenth. So our equation is going to be a squared plus b squared equals c squared. Well, we're looking for a leg here. So we could use a squared, which would be 3 squared, plus, we don't know the other leg, so we'll call it b squared, equals 5 squared. Or if you'd like to, because we are looking for a leg, you could say that leg equals the square root of the hypotenuse squared minus that other leg squared. Or in other words, you could put that the leg equals the square root of 5 squared minus 3 squared. That would be perfectly acceptable. This is a quicker, easier way to our solution. So we're going to have 25 minus 9, which would be 16, and a square root of 16 is 4, so we have 4 feet. But I'd like to point out something here. Remember when I talked in one of the videos about the 3, 4, 5 right triangle? If you can just look at this and see that we have a 3 and a 5 for the hypotenuse and know that that's a 4, you can jump right to that solution. In fact, if I change this leg to 6 feet and the hypotenuse to 10 feet, some of you should look at that and immediately say, okay, that's got to be 8 feet, because this is a ratio of the 3, 4, 5 right triangle. This is 2 times 3, 2 times 4, and 2 times 5. So if I change this to yet another one and I said that this is 25 and this is 20, what is this leg here? Well, this is 5 times 5. This is 4 times 5, so 3 times 5 would mean that this leg would be 15. You should recognize these examples of 3, 4, 5 right triangles. They're in the ratio of 3, 4, 5. One leg is 3, one leg is 4, and the hypotenuse is 5. Problem number 2, how high is the wheelchair ramp? Well, this is a situation where we're clearly looking for a leg again, so we could use either equation. You could have 36 squared plus the other leg, h squared equals 36.1 squared, or you can use my solution, which is the leg equals 36.1 squared minus 36 squared. And whether you do it this way or this way, you're going to end up with problem number 2 with a solution of 2.7 feet. Remember, our unit is feet in this case. Problem number 3. Meredith made a model of a pyramid like the one shown for history class. What is the height of the model? So we have a distance here of 9, so let's draw it over here so we see this better. We have a leg of 9, and then we have a right angle here, and then the other distance we know is the lateral distance here, which is a hypotenuse, and that's 15. So again, since we're looking for a leg, it would be the leg equals the square root of 15 squared minus 9 squared. Or you could have 9 squared plus, we'll use b squared in this case, equals 15 squared. And you could have 81 plus b squared equals 225. Subtract 81 from both sides. You have b squared equals 144, which you should see as 12. So we'll put this up here as 12, and again we're looking at inches here, so we put it in inches. Our solution is 12 inches, but again, if you wanted to, you could just put it into your calculator like this, and just do the square root of 15 squared minus 9 squared, and you will get the answer of 12. And then of course remember to look at your units. Problem number 4, building on the essential question. How do you solve a right triangle? Well, I'll talk this through in words and then we'll turn the answer on and you can take another look at that. But how do you solve a right triangle? Well, it comes down to one of two things. Either you're looking for a hypotenuse or you are looking for a leg. And in every case, you're going to use the equation a squared plus b squared equals c squared. And if you are looking for, in other words, if you have a one leg and a hypotenuse, you put one of the numbers here and the hypotenuse always goes here. You could also have put it for b and then you solve for what's left. If, however, you have two legs, you put one here and then you solve for c squared. Or another way to do it is to use those formulas that I showed you where you can put it right into the calculator. The key is that you have to recognize whether you're looking for a leg or a hypotenuse. And here is what the answer key says about that. You need to determine what measurements represent the legs and the hypotenuse and appropriately use the Pythagorean theorem, which, like I said, would be real easy. You could easily put this in your notes as leg equals hypotenuse squared minus leg squared. So if you're looking for a leg, you use that one. Or you could say hypotenuse equals the square root of leg squared plus the other leg squared. And it'll work every time. Please do independent practice.